Hi. So we are given a function xy plus y squared is equals to 1, and we are required to show that the second derivative of what you have here is equals to that. So this is a very simple question because we have a guide of how the answer is going to look. Okay, so let me first of all find the first derivative. So you observe to say you can use implicit differentiation here. Okay, this is just going to be if you differentiate x and maintain y, this is going to be y plus differentiate y, you maintain x, that's going to be x dy dx plus differentiate y squared, that's going to be 2y multiplied by dy dx is equals to 1. No, that's going to be equals to 0. That's a constant, yeah. That's going to be equals to 0 when you differentiate 1. So now we can make our dy dx the sub of the formula. So you observe to say this is going to be like a dy dx, then that's x there plus what, plus 2y is equals to minus y. Okay, so this is actually interesting because I'm already seeing myself getting closer to my solution, because what I have here and what I have there is they're the same, so I'm not further away from what I'm looking for. So I can say dy dx, this is going to be equals to minus y divided by our x plus 2y. Okay, so that's our first derivative. Remember, the question is requiring for the second derivative, not the first derivative. Okay, so now we can use the quotient rule. I like using the quotient rule. So our u is our numerator, which is minus y. Okay, then our u prime is going to be equals to like the derivative of y is nothing but minus dy dx. So you observe to say our dy dx is nothing but what we have here, and it's negative multiplied by this negative is just going to be what? It's just going to be a positive y over what? Y over x plus 2y, like that. Then our v is equals to what? Is equals to the denominator, um, which is x plus 2y. So observe to say your v prime is going to be equals to, you have a 1 here, then plus what? Plus 2 by dy dx. You're using implicit differentiation. So when you differentiate y, you get dy dx. So you're just going to multiply these 2 by what? By your dy dx, which is this one that you have gotten here. And it basically means this is going to be minus what? Minus 2y divided by what? Divide by x plus 2y, like that. Okay, so now uh, coming up with our d2y dx2, remember you're going to say your u prime by your v. Okay, meaning this u prime by this v here, what are we going to get? Okay, so you observe to say if you say your u is y, divide by what? Divide by x plus 2y. If you multiply this by v, which is your x plus what? X plus 2y. You observe to say this one goes and that one goes there. So we can get rid of that. You observe you're just going to remain with what? Just going to remain with a y. Then minus, you're going to subtract your u multiplied by v prime. Your u is a what? Your u is minus 1. So if you multiply by this negative, this is going to be positive y. Then this is multiplying, of course, your v prime, which if you make it a single fraction, if you go step by step, remember you have a 1 here. If you make it a single fraction, this is going to be your x plus 2y here minus 2y. Then that is divide by x plus 2y, like that. Okay, like that. Then remember everything here is over what? This is over v squared, and our v was x plus 2y, so this is going to be like x plus 2y squared, like that. Okay, so our d2y dx2 is equals to, you have to say that's just going to be your y plus you have your at this point you get a 0. Okay, so that's going to give you yx, okay, divide by your x plus 2y, like that. So this is divide by 1 here, then all of it you are dividing by what? By x plus 2y squared. Okay, this was a bit longer than I expected actually. Okay, so now you can make the numerator a single fraction, and that's just going to give you yx, yx plus 2y squared plus another yx there. Okay, so remember to say this one now just going to be your x plus 2y to the third, when you, because you have this one then to multiply by that one there, that is on the denominator. Okay, so now the question is, why doesn't it look like the other one? I mean this one here. So here we can say this is going to be 2yx plus 2y squared. Okay, plus 2y squared. Divide by what? Divide by your x plus 2y to the third, like that. So remember, our original function was xy plus y squared is equals to what? Was equals to 1. Okay, was equals to 1. So let me substitute here where there is y squared. I write this in terms of y, squared. So I'm going to say y squared here is equals to 1 minus what? Minus xy. So this is going to be equals to, you have 2yx here plus, this is going to be 2 open bracket 1 minus xy, like that. So divide by your x plus your 2y to the third, like that. This is going to be equals to, you have your 2yx or xy, that's going to be plus what? Plus 2 minus 2xy or yx. Okay, this is divide by what? Divide by your x plus 2y to the third. And there we have it. Because this can go and that can go, hence we have our what? We have our d2y dx2 to be equals to, you remain with a 2 on the numerator, divide by what? Divide by your x plus your 2y to the third, like that. This and that are the same, hence we have shown. And this question was actually very interesting. Yeah, so that's how we answer that one. Thank you.